I'm not sure if I really will think about that I'm holding this one. So if I'm talking and doing something like this, remember me. Okay, inside my slides, I will show a few lines of code, maybe. So if your eyes are good, you can sit down in the last row. But mostly it's not bad if you're coming a little bit more to the front, because the size here is very, very small. Okay, half past. I think we will start. Maybe some other people will come. I'm really not used to this one. Okay. So, everybody's prepared? Yes, huh? I think so. Okay, one question. Who's coding Java? I mean, in daily life, and it's not a manager. Okay. You know that this will be a talk about core Java stuff, design pattern. Very old things, nothing hipster. Okay, only to hear you. No? Find a seat. Okay, so my name is Sven, and I'm working for an Italian company in Germany, and I'm based in Munich. And I'm head of R&D, so my daily task is playing around. It's wonderful. So since 1996, I'm earning my money with Java. But this means I have no clue about other languages. So if you're asking me something about why it's something like in .NET, I have no idea. But during this time, mostly, I was working in projects that are a little bit older. Who of you is working in a project that's running 6 months, unlimited budget, no project lead, and mostly no customer? There you are, nobody. Legacy code, who's working with legacy code? And the rest at university? No, okay. So the biggest problem here is that with all this legacy stuff, I mostly have to deal with in a way that, oh, by the way, you turn off the sound from HDMI? Hopefully, because I have, I think, one video with sound, and this is awful. I forget to get rid of it. So the main thing is that if you're working with legacy code, mostly you have the problem that this stuff is constructed by a lot of. So every time you have a huge amount of developers from different countries, ages, companies, whatever, and everybody would like to have his version of structure inside. And then slowly you have to find a way to divide the system maybe in some parts or to clean up a little bit. And some things that are really good are design pattern, and one of this design pattern is a proxy design pattern. And this is a point why I really love this one. And the first thing here is that if you start reading about the proxy, everybody is reading the first version, for example, from this book, from these 4 guys, writing a lot of stuff with funny things. And then you start reading, and then you get cold feet. Oh, this pattern is a little bit more as expected. And then you have this point of, now time is running, I have to make a decision, learn something and start working and dealing with this. And if you're working with this and coming to this legacy code, then sometimes you have this feeling. So standing in front of a huge black whatever, and you have only a little bit amount of time, because this time is limited inside your project and budget, and then working with legacy code, well, something like this, standing there, and then you have to make a decision now. What's going on? What are you doing now? This guy is crazy. A few videos on YouTube from this, and yes. So, proxies. What do you want to do with proxies? I think, oh, maybe I can switch this one. This would be perfect, because then it's easier for me and you to understand me. Okay. No, I don't want to have sound from the computer. No sound from computer, only this one.
It's remote. Remote for presentation.
No, only there. Okay, can you understand me? Sure, huh? Okay, now I can jump, because normally it's too complicated here. Okay, so finally, we have what goals we want to reach with proxies is that we want to extract the generic parts from your application. And the other thing is you want to decouple these old systems because you want to, introduce microservices. Who's working on microservices right now? Really? So in production, not at home? Really? Okay. So the biggest problem is if you have a huge amount of source code, a few million lines of code, and then you want to extract this single part of it, first you have to make a decision what's the border you want to extract. Sometimes it's not clear what's the right border. Sometimes it's easy to put some stuff inside your application to measure what's the right border and then decide later what you really want to extract. Proxies could help there. And the other thing that you want to have is hiding technical stuff. Because, yes, you have a remote call or remote communication, but maybe you don't want to see it everywhere. Okay, so the other thing is, if you know a lot about proxies, okay, but it's a completely different thing to write good proxies, if you want to have latency-free proxies or whatever. So you have to make it easy to use. And what I would like is something like this. You have, for example, this one, and you say, okay, for this interface, I want to have a proxy. For this, I want to have a proxy builder, for example. And for this proxy builder, I want to have a customized proxy. For example, I want to add logging. Or maybe, this time I want to have metrics here. Or even security rules, whatever. But I have a few of them, and then at a certain time, you want to say, now it's the right time to build the proxy. What you have is, you have the possibility to add cross-functions somewhere in an easy way. The next thing that's really, really good is that different parts can customize a proxy, and the last good thing is a complete other time point would give you the possibility to create it, and during this time you have the possibility to make a proxy in the right order, but we will see it. The other thing is, if you're working with dependency injection, why you never have the possibility to customize your proxy. So in the most dependency injection frameworks, you could say, give me a lazy or something like this, but never you could see something like, okay, I want to have a virtual proxy, but please add metrics or something like this. So proxies must be customizable in a very easy way. Okay. But mostly I see something that the proxy and the adapter is not really, they're using it mostly in a nearly same way. So the first thing I would explain is that if I'm talking about an adapter, I'm talking always about an adapter with delegator, and the thing is, an adapter is completely different in a way. So let's assume we have a legacy worker, something we have to work on, and then I have an adapter. That means I have a new signature of this method, and if I'm implementing it, I have here the thing that I want to get rid of this array, and I want to have a list because this is now needed, or nicer, or whatever. So the only thing that's inside an adapter is really the transformation from one signature to the other signature, and nothing else. That's part of the adapter. And then you have, for example, here, the legacy worker, an instance that you are delegating through. If you're dealing with an adapter, it means that you're creating an adapter and you're working on the signature, but you have no need to know about the legacy worker. It's hidden. And the other thing is, you're not inside the inheritance. You're not extending the interface, you're hiding the old interface, and there's only the transformation from one signature to the other one, and mostly you have the same creation time of the delegator and the adapter. So, and all this is not a proxy. So what's the easiest way of a proxy? So, To change this one, we need to know the old legacy part because proxy has the same interface. Inheritance between legacy worker and the adapter, or better, the proxy, and don't use a proxy like an adapter for switching signature, so divide it really. If you want to change signature, use an adapter, call it an adapter. If you're using or want to have a cross thing that you want to implement inside your application, then call it a proxy. So what's the easiest proxy we have? So I only want to go here straightforward because we want to have some more complex things. Expect that the service is the interface you have, and you have a very easy implementation here. The easiest proxy you could have is this one. So you are inside the inheritance because you're implementing the interface. You're not extending with other methods, so you really could replace it. You have something that is the old implementation or something different, and it's the thing you're delegating through, and then you could work on it. That's the easiest proxy you could write, and it's doing nothing. It's completely useless. And now we want to extend it. The proxy, the family of this proxy pattern is it's a huge family. And so I want to give some examples of very typical groups of proxies. One is a security proxy. What's the biggest problem with a security proxy? Any idea? Mostly the thing is that security stuff will be added later during the project. At the beginning, everybody's coding, and then later you're adding security. But what's the target of a proxy like this is, for example, allow the execution yes or no. And this will lead you to some things you have to have in mind. For example, a very easy implementation here would be that you have this delegator. It's a very easy security rule, so check if this is the same. But the biggest problem you have to have in mind if you say execution yes or no is that the return value or the amount of return values must have a dedicated value for not allowed. And mostly people are forgetting it. So they say, okay, it's not allowed, and then maybe an exception, a runtime exception, and this could bubble somewhere, and this is not good. So if you have something that's going over the whole application and something like it's allowed, yes, no, make sure that the return value that is expected have a dedicated value for not allowed. And this will extend the amount of values compared to the original. So how to deal with this? This is something like this. It's only a very small one. Another group is a remote proxy. Remote proxy is an example for proxy that is hiding technical stuff. For example, you have this service and the remote proxy. What the target of a remote proxy is, execute something outside of my process. No? Maybe, could be. I would say yes. So if you're working with this, you're dealing with this in a way that you're creating the remote proxy and then working on it. So you don't see that there's any remote stuff, but a remote proxy is an example for hiding technical stuff. That means, who knows that, later. So what's going on? So there's a request, we have an interface, then an implementation of this proxy, and if you have remote communication, think about you have a bidirectional communication, so there must be coming something back, and this could happen or could not happen. So how to deal with failures here? You have an interface, and then you have on the other side the implementation. That's the second part of it, and then going through the next system step. So we have a client, we have a server, and then we have to deal both on the same interface. This means mostly I see interfaces like this. What's the bad thing here at this interface? It's full of technical annotations. Get rid of it. So if you have something to hide technical stuff, it would be a good advice to extend from this service to my remote service with the same signature, and only in this interface put all this technical stuff so that you can get rid of it, not only get rid of the proxy, but the full technology. Mostly the people are forgetting it and writing technical stuff on the interface too. So checking here, I want to see what's a remote service. By the way, who knows that the JDK has a SOAP endpoint? Who worked with this? Nearly nobody. but it's part of the JDK. So you can write in SOAP endpoint with Core JDK. So, but here, the implementation, it's the same with the interface too. It's a lot of technical stuff there. It's only an example. I don't want to explain all this stuff, but get rid of this at the implementation too. This means on the server side, if you want to publish, this is an example of how to do it with Core Java. You can have a fixed thread pool, and then you can say, okay, my endpoint will be created with this implementation, and then I'm publishing this endpoint. Now you have a Core JDK endpoint. Sometimes it happens that the customer say, yeah, we have 200 requests per minute, but we have a huge JBoss. And then you can get rid of it and writing a few lines with the remote proxy. So the only thing here compared to the whole implementation is that you have here this implementation that you're publishing outside, and the rest is technical stuff. Okay, and the same on the client side. I don't want to go to the details, but here is the same. The technical part that you're using is most of it, and you have only a few things that are really dealing with implementation. That means remote proxies are mostly to hide technical stuff. This is a technical part. This is not really an interesting design pattern. It's only how to extract technical things, but it's part of the group of proxies. Okay, so for remote proxy here is remote communication. It's mostly technology-based work. It's not the design pattern itself. And the goal is that you're not seeing using a technology and to get rid of it later. That's it. So these are very easy groups of proxies. Now we are coming to the interesting thing. This is a virtual proxy. What's the goal of the virtual proxy? Until now, we're always talking about something will be created and used. But we are managing, for example, security stuff, yes, no, execution, or technical stuff using a technology. But the thing now is we are dealing now with timeline. And timeline is a huge topic. That means the basic idea for virtual proxy is create the delegator later. Why? Why I want to create the delegator later? It's a heavy object, maybe, yeah? But you can do so many things. Imagine, you have a server, and there will be the implementation of an algorithm, two implementations. One of this implementation would be very fast, but using a lot of memory. And the other implementation of the same algorithm will be a little bit slower, but using definitely less memory. And then at runtime, you could decide which implementation you want to use. That means the amount of memory that's used is increasing, and at a certain part you're deciding, now switching implementation. This could be done very easily with a virtual proxy. And then if you have less memory usage on the server, you are switching back. So you can create something like dynamic reconfiguration on it. With Core JDK, only a few lines of code. So managing timeline is a huge topic. You can have different A/B testing, you can have patches, you can have whatever. So the amount of things you could do is really amazing. But how to deal with this? For example, you have this implementation. The main thing is that in the beginning, the delegator is not created, and then later I'm creating, and here it is, if the first invocation of work will be done, service is equal null, so create this instance. Is this a good implementation? No, otherwise the talk will be finished. Huh? So, at this part, if I'm dividing it, there is few things that I want to change. The first thing that I don't like is this one, equal, equal, null. What does it mean? What's the bad thing here? It's not thread safe, huh? So this is not thread safe. Sometimes I need it. The next thing that I don't like is that I have here a fixed decision for implementation I want to get rid of. And the third thing I want to get rid of is this one, new, because I don't know how to create this thing. It could be more complex. So maybe we could combine it with a factory pattern. This means writing the same virtual proxy as before, I want to say this new I would extract in a service factory, for example. If I have this one, then I could say this decision at what time to create a new one would be a strategy factory. And this completely different things. You can implement very generic. And then the same implementation would look like for the new. I'm creating the new constructor. That's the easiest implementation of the service factory. And this one will be an equivalent implementation here as we saw before. So only check if it is null and so on. The good thing is that if you are now working with this, your proxy would be implemented like have an instance of this factory, have an instance of the strategy factory, and then if you're invoking work, please return a value. And then before ask the strategy factory, what's the right way to decide it's the right time to create something? If it is the right time, then please service factory create an instance and invoke the method. So this means if you're dividing these two things, the strategy and the creation, if you divide it in two parts, you can write the strategy in a very generic way, and later you can combine it in a way that's very easy and generic, so you don't have to write all combinations by hand. That means if you want to have a synchronized one, it's the easiest implementation I could change now, would be the same factory here, but the strategy will be different. The only thing is I added synchronize. Why am I using this one? It fits to my slides. And then you have a thread-safe implementation. But if you have the possibility to change the strategy, what could you do? Very easily, you could think, okay, I have an old implementation and, well, it hasn't stayed. I'm not really clear how to clear the state and all this one. So I do something like method scoped. So, okay, the creation is the same. It's only the new operator. But then I would say, okay, with every invocation, create a new instance. So with every method invocation, I have a fresh new instance. So there's no thing between two method invocations that could break my work or whatever. So because I can't change the old implementation, whatever. But thinking a little bit more, you can create pooled instance. You can create whatever. So there's a very easy way to have more flexibility of this usage and creation strategy itself, and it could be implemented. But if you have proxies, you mostly will end up in cascaded proxies because you have different things you want to do. But if you're checking here, there are two things that are very, very stupid. Because if you have a remote proxy, go in remote, then you have a virtual proxy and then decides it's not allowed to execute, it makes no sense. You have done a lot of work you want to get rid of. And the same is virtual proxy in the beginning to check after this a security rule and then going over remote communication is not good. This means, who's talking with his neighbor or his colleague during the time you're working? Nobody? Yeah, it's typical for the software developer. That means you're doing some stuff, and you're doing some stuff, you're in the same team, and then the result would be a cascaded proxy. So you have to make sure that this is not happening. Because you're the first one, yeah, and you want to have a lazy one, and you have the security context. And then you're putting both together in the wrong order. And to make sure that this is not happening, you could deal with some things. But let's see how to cascade proxies. I only want to add here a security proxy with a virtual proxy. The first thing is call a proxy what it is. If it is a virtual proxy, call it a virtual proxy. And then you have, for example, the implementation you're delegating through, it could be another proxy. But then if you have a secure virtual proxy, please call it a secure virtual proxy because a virtual secure proxy is not the same. And then you're delegating through the proxy itself. What is a bad thing here? You have enough time because everything is hardwired. It must be more generic. But how to do it? So we need a generic proxy. And, well, since a few days, since JDK 1.3, we are dealing with a dynamic proxy. Who's working with dynamic proxies? Yeah, it's not so often, but yeah, it's a new thing, huh? Yeah, fancy stuff. So with dynamic proxies, we have the first JDK stuff that we can use. And how to use it, it's quite easy. It's part of your JDK. So you have reflect proxy, and you need an interface. That's the bad thing here. I will show you a way that you don't need interfaces, and you need an implementation you're delegating later. So this means the easiest one, what's using it? Clear. Okay, we're doing it step by step, I think. That means creating a dynamic proxy is you're dealing with an interface you want to call through. Then you say, lovely proxy, I need a new proxy instance. Then you say, please, here is a class loader you're using to find everything you need. And then there's a bunch of interfaces that must be implemented. And then you have something like an invocation handler. The invocation handler itself is a thing like an aspect that is wrapping around every method invocation. And this is a point where you can add functionality. So if you want to deal here how to make a virtual proxy, quite easy. We only have to extend this invocation handler. So this means invocation handler is here. We are adding this implementation, and later we say, with the first invocation, we are creating an instance. So it's exactly the same what you have done before with handwritten stuff, with the overhead of reflection, sure, but how to make it more generic. So, okay, let's say I want to get rid of this here because this could, I don't want to write it for every interface. The same is here. To get a class loader could be written generic, and the interface I want to implement is coming from outside. Everything could come from outside. So it makes no sense to write it here definitely with an interface. The next thing is I have to get rid of this special implementation. So we have to remove this one. And the next thing is that the thing I want to delegate through, I could get from outside. So now we're extracting the generic part. If you're doing all this, it's mostly called a proxy generator. Okay, how to write a proxy generator is quite easy, because if you check all the green things, then it's exactly what we are using. We are using generics, and then I can write proxies in a generic way. It's easy. Okay, now we are able to define things in a generic way and using it for every interface I want to have. Okay, the good thing is invocation handler is a functional interface, so if you like Java 8 syntax, you can write it a little bit more compact. So, dynamic proxies. You're writing less code because you have a generic proxy here, part of the JDK. You can use it everywhere. No additional library, that's good. And you can create all kinds of proxies with this. But we need to combine proxies. This we haven't talked about until now. Always we are talking only about creating one proxy. Okay, so if you want to combine proxies, we have normally to switch from the factory method pattern to the builder pattern. And with the builder pattern, I can give you a nice interface to create proxies, but how to combine? Let's say we have a security proxy, and a virtual proxy. You have a few ways of cascading proxies. The first one is you have one security proxy and have two rules. And the second one is for every rule you have a dedicated security proxy. I would recommend the last one. If you have one dedicated task, create one instance of a proxy through it. It makes it really, really easy. But in total, we need a cascaded proxy. Otherwise, we can't put everything together. So you have a few ways of doing it. If you have different proxies here, you can decide you're writing your code in a way that's the last proxy and then putting proxies inside, or you're having the delegator and putting proxies around. Normally, it's easier to implement if you are putting the stuff from the deepest one and wrapping proxies around it. So from bottom to top. Example with end security rules. If you have a security rule, an interface, and this is a functional interface here, you will collect all security rules in a array list, for example, and then later you would say to a dedicated time point, now create all security rules. But in the same order, they are added to the builder because there could be an implicit mining behind. That means with the builder, you can collect over different steps all informations and then later building in the right order the proxies. If you're doing it with the dynamic proxy here, the gray one is typical stuff. The thing is that you're building it from bottom to top. You have to remember the last child. You have something like an original, the last child. You want to work and then inside the invocation handler, you're setting the child for the next level. So if you're doing it this way, the code is quite easily. And now we're only adding proxies with the same interface. We're only cascading the same interface. Maybe this is not enough. So, but if you're on this level, we could cascade proxies. We reach one goal I mentioned before. Now we are able to write something like, please give me a proxy builder, and then add something, add the next thing, add security rules, and add more security rules, and build it. So with these few things, we got this one. But there are few things that are not nice. So the next thing is, until now, we only cascaded the same interface, and how to deal with different interfaces, how to build more complex proxies inside. The first thing we have to think about how to combine a few things, and this means we need a generic nested builder. If you solve this problem, we could generate for every special proxy a builder and then put everything together to a big proxy builder with dedicated features for every proxy. Now think about a car. Has nothing to do with proxies at the moment. A car will have an engine and a few wheels. Let's say normally I could find code like this. You have a car builder, and the builder will look like this because the IDE will create the builder. But there's a problem. There's a complex attribute. And for this complex attribute, I'm generating a builder. Okay. And for the wheels, I have a data structure. Oops. A data structure, and then there are complex attributes inside this data structure. And this will lead you to code like this, that you say every wheel will be created by a bunch of used builders. Okay. And if you're putting everything together, you will have code like this. And if I see code like this is not nice, definitely, because the developer has too much time. How to get rid of it, how to combine it. This is a target. So let's say the first thing here that's not good is that you're dealing with builders, and in the middle you have a data structure. And then you're dealing with builders together. So if you want to extract design pattern here, you have to get rid of this data structure and make code homogeneous. It must look everywhere the same. And this, I want to get rid of this data structure. That means the first introduction would be a wheel list builder. Now I have only builders. The good thing is, if I'm introducing this one, I could go to a point like build, because how many wheels I'm adding? 3. It's an Italian car, huh? So if I have a dedicated build method, then I could say, now check if you really have 4 things. So you have different points of validating your construct. And now we have to combine this one. So creating the wheels and then putting to the wheel builder. So how to combine this? If you have this one, this is quite easy. So let's say we want to get rid of this one. Huh? Oh, I played with animations, sorry. It was one of the first slides I was dealing with, this tool. So the thing is, I want to have something like this. I want to have a wheel list builder and would say now add wheel. Now I'm switching to a different kind of builder. Then I'm adding all the attributes and say, okay, now I'm done. This means here at this point, I'm going through the wheel builder. From this method point, I'm going to the wheel list builder back. Now I have the possibility to have very specialized builders with their attributes, but only the amount of methods are available at a certain point. So putting it all together, now we have to combine everything, and the good thing is this is quite easy, or the result will be quite good. So get rid of all this stuff. And next one. So this is the result. You have a car builder, you add an engine, going through all the attributes, says, okay, I'm done. Now you are getting the add wheel thing, and then you are putting all this stuff. So you have a parent-child builder combination. And to implement this in Java is quite easy. So this means you have a nested builder. And this nested builder knows that there will be a build method. And the good thing is you only have to recognize that the parent will connect itself to the child. If you're going this way, with a few lines of code, you can create a nested builder, a generic one. This means the nested builder itself has a method done because you want to switch to the other one, and then you can get from the parent the class, and what you know is you have a build method, you know it, and you normally have a naming convention that your parent will have something with and then child. And if you have this naming convention, you can set yourself to your parent. And with this bidirectional combination, you can build a lot of stuff, because this is using the naming conventions of connecting both via reflection. Connect itself with a parent. Okay, this means the basic steps in words is you have the parent builder will hold all the child builder. Okay, the parent builder will have an add child method to switch, and the child builder will extend only from nested builder. That's all. You don't have to do more. And then the rest could be generated by the default IDE builder generators. So that means if you have an abstract way of a parent with 2 kids, the only thing you have to add manually is holding the builder and connect yourself, the last one, with parent builder this. It's the only thing, and this you can generate because it's all inside static semantics. And the next one is switching to the child builder. If you have this, the child itself needs only the extension nested builder. That's it. You don't need more. Only a few lines of code, and you can build this one. No bytecode magic. What you're creating now is you have a parent, and you can have complex childs. But you could be parent and child at the same time. This means you could build a tree of builders. And with this, you could combine now a lot of special proxy builders together to a huge one to make sure that everything is in the right direction. Okay. One functionality leads to one proxy instance. That's always good. Runtime overhead for every proxy is there, yes, but make it first simple, then optimize. But until now, we always talked about switching implementation instance, completely instance. Why not switching methods? The DynamicObjectAdapter, first introduced by Dr. Heinz Kabutz, leads you through the following. You have a proxy, and then you will decide if you want to invoke this method on original or on something else, on an adapter, for example, or from other implementation. And then you're invoking A or you're invoking B. So now you can switch implementation on method-based. But the adapter you're using here is not inside the inheritance. That's a good thing. So switching between method implementations will give you the possibility to change only small parts, and how to identify a method is quite easy. I will show it to you. Say we have a service with a method and an implementation. What I want to find out is what you need to identify a method. And in Java, it's quite easy. You only need the name and the classes from the signature, from the input. And with this, you can build a key, and this key you can store in a hash map. And the hash map will have the key and something you want to invoke. And now you can switch. The implementation, if you're using DynamicProxies, is quite easy inside the Invocation Handler. You have all the adapted methods. You have the original one. You want to delegate through if you have no adapter. And you have the instance of the adapter where all these methods are implemented in the original version. So adding adapter is putting your adapter here, getting a class, getting declared methods, create all these method identifiers, and putting this one to a hash map. So this is quite easy code, and now you can switch between implementations. So an invocation of a method will lead you to the reverse way. So you know that you will have a method that will be invoked. then you could create this method identifier. You check your hash map. If you have a different implementation for this method, invoke this one, otherwise the original. But there are a few things that I definitely don't like. The problem, what could be here is a problem, and what could be improved. There are some things in Java that I don't like at this point. But first, let's think about the following. If you have a service interface and there are the methods, then you can have an adapter with a method that has the same signature, but someone starts refactoring, and then you have something like a change in your method signature. And at this point, you would have inside your system 2 different versions, and this means that you could add adapters that are completely useless. They could never be invoked, and you could find it only during runtime, and I want to have it during compile time. This was the first thing. You have this proxy switching between implementations and then invoking what. Let's say we're extending this one a little bit. That means you have a service interface with a few methods. And for every method you have, or for this interface you have an implementation. But think about dividing this interface. You have this original interface, and then you start creating with a naming schema different functional interfaces, and for every method, a dedicated functional interface. Why? We'll see. Because if I have this one, I could do something easier to use. I have the same that I don't have only one adapter, now I have a bunch of adapters. For every method, I could add a single dedicated adapter. So not only one adapter, I have a bunch of adapters. So if I'm adding an adapter, I'm getting all these methods, and all over the methods, I'm creating this one and adding the adapted methods and the adapter to 2 hash maps. I only extended it a little bit. That means if I'm invoking, I'm creating first the method identifier, check if I have something adapted, and then getting this one, or I'm invoking the original one. This is not the problem. There's more or less the same, only I increase the number of adapters, so every method could be independently adapted. That means now I want to introduce a builder, because I want to make sure that here I couldn't add useless adapters. Because the builder will have some with methods, but the input for this with method would be exactly the functional interface I created from the main interface. So I have this first interface, then I'm creating all this functional interface about it, and every functional interface implementation will be the input param for the with method of the builder. Everything is now statically typed. I can't add useless adapters. So it was something like this. The interface and then writing special interface for every single method. So what could you do with this? You could say, please, I need an adapter for this interface and this original implementation, and I only want to change this single method and build something. But in the same time, you could use it like a mock, because you could say, okay, for this interface, and I have no original, because I only want to test one method, I only want to implement one method or whatever, I don't have to create the instance of this implementation, and then I can say, okay, this one I want to have for my JUnit test, build it, use it. Quite easily. And if something's changing, you don't have to recompile because you have only this one. But too much boring code to write if you're doing it by hand, and if you want to have a type-safe version, you want to have a break in your compile if someone is changing something that's not really interesting or not good. So this service interface, remember, has 2 methods, and you want to create this one. How to do it? Since Java 1.6, we have annotation processing. So it's quite easy to write an annotation, put it to your interface you want to have a DynamicObjectAdapter builder through for it, and then during the compile time, this annotation is not so much work to write. You have to implement an annotation processor. And then during compile time, everything will be generated, because the builder could be completely generated. The functional interfaces could be completely generated. And then you have the possibility to use this DynamicObjectAdapter in a type-safe way. So The good thing is you are working now with functional interface, and mostly this will lead to functional aspects, but it's okay. This was based on the dynamic proxy. This means you have reflection overhead. And if you want to get rid of this one, and with proxies, you have to generate proxies statically. And you can do it with annotation processing. Here, for example, the same, but now I'm introducing not a dynamic object adapter, I'm introducing a static object adapter. So from this point of view, I'm creating all these methods. It's the same way. I have these functional interfaces, and now how to write a static object adapter? Easy as expected. I have the original, I want to delegate through if I have no adapter. And then for every single method I want to adapt, I have a reference to a possible adapter. And then if I'm invoking a method, then I could check if I have an adapter, invoke this one or the original one. So. And the good thing is it could be completely generated. You don't have to write only one single line of code by yourself. And the JIT compiler can really optimize this stuff. If you have more than 10,000 invocations, then you have nearly no overhead here. The good thing is if you're generating code, add annotations to mark your generated code. For example, don't write only generated, put an static object adapter, or is object adapter, or is dynamic object adapter, so you can write tooling for it. And then you can write really cool plugins for your IDE to deal with proxies or with dynamic object adapters. It's quite easy. But all this stuff is not enough. It's not fast enough. And that means that you can change the interface you're working through. The dynamic object adapter stuff is only usable for interfaces, or if you have an interface, because you're using dynamic proxy. The static object adapter, you don't need interface. You can do it with classes only, because you're generating all the stuff around. So it's more flexible. But sometimes I want to have the possibility to say, I want to do it at runtime. Not during the compile time, I want to have it at runtime. I'm getting an instance, I know I have to add metrics. Now I want to reflect what's there, creating source code, compile it in memory, no round trip over the hard disk, putting it to the class loader and say this proxy is now active. So if you're dealing with this, you're going now to some really black things in Java, but well, let's say, what is a basic thing you have to have in mind here? How to compile and how to give it to the class later. This work is based on the newsletter from Heinz Cupboards, 180 and 181, so you can read there the basic stuff and then you can extend it. The main question is how to compile in memory. Anybody who tried it? In memory compile? Say, on the fly? That's easy. And also write class loader, because you want to activate your proxies. So how to compile in memory is a little bit tricky to find out. There's not really an advice how to do it. So you need the Java compiler from the tools jar, and you need a holder for the source code you're generating. And this is, don't worry, the slides are online available, so if you can't read it completely, you will do it later. But the thing is, you have to find out that the simple Java file object you have to extend, and then you have to create a holder for the generated source code. This is only, you have to try it. And then after a few tries, you will find it out. The next thing is you need a holder for your bytecode. So this means you need a simple Java file object, and then you need an output stream, byte array output stream, so that you can hold the generated bytecode. So source code we have, bytecode we have. Now how to compile. The compile, we want to use a forwarding file manager, because with this one, we want to make sure that the default behavior of writing everything compiled to disk we don't want to have, because this is latency. You need a few hundred milliseconds for this or whatever, and if you don't want to have it. So you have here, for the generated bytecode, a holder too. And then you have a source code, bytecode, this file forwarding stuff, and now you have to put everything together in the right way. It's a little bit source code, and then to invoke this Java compiler. So You can read it online, so how to add diagnostic collector and put it in the right way together. So it's more technical thing. It's nothing you need to understand the idea behind. And in the end, if you're combining all this stuff, you have generating source code, compiling it in memory, you have a holder for the bytecode, and this in-memory holded bytecode you have to put to the class loader. And then you are quite fast. So you can create proxies now during runtime for classes you don't know before, but you can add cross-functional stuff. And if you have source code, the good thing is, asynchronously, you can write down the source code so that you can analyze it later, or can give it to someone to validate it, or whatever. It depends on the system you have to work through. The class loader itself, it will change during Java 9, because one thing is you can use something unsafe. This will be changing, and then proxy-defined class area. But the biggest problem is how to give this generated stuff to the class loader is always JVM dependent. So you have to check it for the JVM you're dealing with. So, but this solution will give you the possibility to have, you can create proxies at runtime in a customized way. You can combine all this stuff and you have nearly no latency because you're putting all this stuff together without reflection. So, what does it mean? We talked a little bit about proxies. So this guy is going deeper and deeper. He's doing it regularly. I have no idea how he does it. But what we have done, we have seen that the basic proxy pattern is quite easy, but you can extend it. You have different group of proxies. You have a proxy, for example, to hide technical stuff. You have the proxies to think if something will be executed, yes or no. But the biggest thing is how to create the delegator later. And with this, you can do a lot of stuff. We built this pattern for a single proxy with a dynamic proxy. And then we thought, what could we do to combine proxies, to have a cascaded proxy with the same interface? With this one, we could now have more proxies in a row. If I have proxies in a row or in a queue, the good thing is during runtime, I can go through and say, okay, now at this point, I'm removing proxies again. This means if you want to add the possibility to measure metrics, you can say, for this class now, add a metrics proxy. You're putting this proxy inside during the runtime. And then you're measuring all this stuff you want to have in production, and then you want to get rid of it. You're removing this proxy. You can get rid of it. It's not bytecode manipulated stuff. And then you can add all this stuff again and again and again. So with this cascaded proxy, we thought about how to make it more comfortable for someone who's dealing with this. So writing a good proxy is a hard topic. But using a proxy must be easy. So we introduce a proxy builder for a very simple one that can deal with if you have a dynamic proxy. The next thing is that a proxy itself could be very complex or a little bit more complicated to configure. So you have a dedicated builder for one proxy, but if you want to make sure that a cascaded proxy or a cascade of proxies is useful, so that the security proxy will be always the first one and the virtual proxy will be always the last one in the queue, you can use this builder to make sure that it's independent from the order you are using the add or with methods, and in the end you will have the right cascade of proxy. And with all this stuff you can do at runtime and so on. If you want to deal with this, I added this www.proxybuilder.org. It's an open source project where I put all this stuff together because I'm using it in production. In the same way, the proxy itself is a basic design pattern for dependency injection. And if you want to play a little bit with a dynamic dependency injection, this is using. Both is Apache license, both is open source. If you have questions, ask me. And I hope I could explain a little bit with the source code how to deal, how to use it. And yeah, well, maybe it will help you sometimes. So from my point of view, I'm done with this talk. If you have questions, come to me. I'm here, or write me, or hey, follow me on Twitter. Thank you very much.